Hello, everybody. Welcome to our session. And today we're going to be talking about how to enhance your security posture and run PCI compliant application with Anthos. I'm Harish Jayakumar. I lead the application modernization team here at Google Cloud. And today with me, I have Anne.
Hi, I'm Ann Wallace, Security Solution Manager with Google Cloud.
Thank you, Anne. Let's jump in. So, when we talk about running regulated workloads, it can get quite complex, especially because there are multiple stakeholders that are involved in it. On one side, you have the makers, that's the developers, the product owners, and the enterprise architects. And on the other side, you have the checkers, which are the security teams, risk and compliance team, and the legal teams as well. So, because of these complexities, regulated workloads are the slowest ones to move to the cloud or even to modernize. So, in this talk, we're going to be exploring how to modernize these workloads at the same time meet the compliance requirements either natively on Google Cloud or if you want to run them on Prem using Anthos. Now, running a regulated workload, especially for PCI, in this case, when we're talking about for this one, is challenging because audits can be quite daunting. Why? One, compliance frameworks were not built for cloud native architectures. Two, it actually takes a village to pass an audit to demonstrate the compliance associated with it. And then three, you want to also avoid misconfigurations. And if there are any, you have to fix them. And then finally, evidencing a shared responsibility. Especially today, when we talk with customers, most of them either have a hybrid model or they're on multiple clouds. So, understanding that shared responsibility becomes very, very important. Which brings you to this slide over here. How does this fit into the shared responsibility model? So when we're looking at simply, for example, running Anthos on Google Cloud, or if you're running Anthos on Prem, you can see the difference over there. Simply running on Anthos Cloud, you see a lot of it is actually handled to you by Google itself. And the customer only needs to focus on the application, some configuration associated with that, and some base images. Whereas the picture completely changes when you move to Anthos on-prem. There's much more control the customer has to take care of maintaining the node hardware, the networking, the storage, and the physical hosting. So we need to be able to see, for example, if something happens, something goes wrong, who's responsible for it? Let's take example, for example, when an identity management is done. To whereas on the Google Cloud, you can actually leverage the Google Cloud identity in some form or the other with Cloud IAM, and then we can handle that for you. So, customers are starting to adopt Anthos to build the next generation digital platforms. Modernizing the security for cloud native deployments is a great use case where they're actually using it. And the key objectives for these modernizations are one, increasing the developer productivity through the use of containers and microservices while adopting hybrid and multi cloud as deployment platforms. Now, many of these customers processes sensitive data that include PII, PCI, and PHI. Further, they must also meet their regulatory compliance. But as application teams adopt new technology stacks and development processes, using the existing paradigms and processes is no longer optimal or even sufficient. So, in order to deliver the developer agility, the security stack also needs to evolve to align with the new development and rollout processes. It must also address new threats that apply to modern production environments. Now, let's pivot quickly to the compliance requirements. So, we've taken some of the compliance frameworks, such as NIST 853, which maps to FedRAMP, PCI DSS, ISO 27001, and have identified some common technical requirements. They actually fall into these five categories: segmentation isolation, identity access management, data security, supply chain, and application security. Now, we don't have time to dive into all these 20 in this 25 minutes talk, but we'll talk about how Anthos can help with several of these requirements right out of the box. As you can see, the same five requirements, we've put them down into five pillars. And out of the box, Anthos offers a lot of security capabilities. Each control aligns with the common compliance requirements that we talked about in the previous slide, whether it's going to be segmentation and networking, IAM, data security and encryption, secure supply chain, and application security. So, as you can see, most of these features to help you achieve your security posture. But as I mentioned before, it's the shared responsibility model, and you need to know how to blend the controls together appropriately and understand what you are responsible for. For that, what we're going to be introducing is Anthos blueprints. And to talk in detail about that, I'd like to call back Anne. Anne?
Cool. Thanks, Harish. So before we dive into the Anthos blueprints, first let's talk about our security blueprint. So we've designed security blueprints to help some of this complexity that Harish described to simplify it. So The first security blueprint we have is called a security posture. So this is a collection of resources and code that deliver granular and specific security postures to a workload, such as maybe a customer-facing application or back-end process. For example, securing data or securing API endpoints. The next one that we offer is called a landing zone. So this is a pre-configured environment with a standard set of secure cloud infrastructure, policy, and guidelines. So this can be something that's otherwise very complicated to set up and might take months of investigation, implementation by trial and error to get right the first time. So an example of this is PCI for Anthos. Regardless of the type of security blueprint, they're all designed to be easy to use and deploy. And we also employ all of Google Cloud security best practices in the blueprint. So you can say they're secure by default. So one of the first security landing zones that we released was PCI on GKE. And coming soon is PCI on Anthos. So these help customers get started with compliance on Anthos quicker. So it also allows you to quickly and easily deploy workloads on Anthos that align to PCI DSS in repeatable, supported, and secure ways. So let's look at everything that's included in the blueprint. So the PCI and Anthos blueprint contains many opinionated reference architecture diagrams depicting the infrastructure and application deployments. While they're intended to be used with deployable assets, they also show you how to create diagrams of your containerized card holder data environments and the boundaries between PCI and non-PCI workloads, which is a requirement in PCI audits. The blueprint also contains different deployable assets. And then we also include PCI DSS 3.2.1 mappings to the solutions and a compliance white paper. So with our Anthos on GCP blueprint, we provide you with Terraform templates to set up your infrastructure. These include org policies, projects, VPCs, and GKE clusters. And as Harish described about the shift in the shared responsibility model, our on-prem, we only provide you with reference architectures for squares 1 and 2. But with both of the blueprints, we provide you with service mesh profiles, GKE configurations, ACM policies, and then a demo app to test out the environment configuration and setup. So let's pivot to segmentation. There are two types of segmentation. So the first one is macro segmentation. So these are things that you do inside or outside the cluster. So you segment the users, networks, and applications using different Google Cloud features and tools. This really helps you set aside the scope of the audit. And then we have micro segmentation. So these are things that you do inside the cluster. So let's double click on that a little bit. So with GKE microsegmentation, we offer many ways to do this. So we have network policies. This helps with layer 3 and 4 network level segmentation. Then we have GKE namespaces for virtual clusters to segment teams or maybe app versus prod or app dev versus prod. Then we have GKE private clusters. So you have clusters with private IP space and then Anthos service mesh. But the net here is there are many ways to do microsegmentation in a cluster. So for the PCI on Anthos on-prem blueprint, the first layer of segmentation is addressed through separate clusters. So we create two clusters, two user clusters, one for in-scope or for your card holder data cluster, and then one for the out-of-scope workloads. And then building upon the segmentation, we have segmented out of the pods within a cluster, but you further need to demonstrate separation of maybe dev and test versus prod environments to your auditor, or you need to segment application profiles. So this is where you would use different namespaces. And then oftentimes you're presented with a requirement to protect the routing information and the private IP spaces. This is where you mark a cluster as private. In such a cluster and the master become inaccessible from the public internet. And then the nodes in the private cluster do not have public IP addresses. So the admin and user clusters are private for the on-prem blueprint and the GCP blueprint. So looking at some of the reference architectures that are provided as part of this blueprint, you can see here that, again, the in-scope and out-of-scope cluster separation. And then we have Anthos Service Mesh. So it's a single mesh for multi-clusters. And then our demo app is called Online Boutique. So this is an e-commerce microservices demo application. So this allows you to test out the controls and the architecture. The PCI DSS audit burden is minimized by moving the microservices from that demo application that don't touch payment card data into the out of scope cluster. This reference architecture details this layout. This also helps you with your own architectures and documentation. And then looking more specifically at PCI requirements. So PCI requirement 4 talks about encrypting data in flight, specifically of cardholder data across open and public networks. For our on-prem blueprint, the in-scope and out-of-scope clusters are in separate networks, which helps with strong isolation for PCI boundaries. This also means that the cross-cluster communication must go through an Istio gateway. All cross-cluster communication uses mutual TLS authentication and encryption. Citadel is also included for managing the internal certificates. So a lot of the blueprint is for day 0, but we also want to talk about day 1 and day 2 sort of scenarios. So this is where policies, code, or shifting left happens. So you want to, setting up initially is great. Everything's PCI compliant, but as you're deploying new containers or new code into your environment, how do you make sure these meet PCI requirements? So to help with this, we have binary authorization, Anthos config management, and Anthos policy controller. So let's look at these in a little bit more detail. So for a requirement such as establish a process to identify security vulnerabilities, you can use container registry vulnerability scanning. So this checks the images that you push into the registry for known security vulnerabilities. It is constantly refreshing its vulnerability database by ingesting corresponding vendor security feeds so that you can be notified of new vulnerabilities that may be previously affected scan containers. You can also tie this in with PubSub to get notifications, so you can integrate this in with your CI/CD process or file bugs for newly discovered vulnerabilities. And another requirement is to ensure all systems and software are protected from known vulnerabilities. This is where binary authorization can help. So it ensures that only properly signed containers are deployed into production or other environments. You can use binary authorization to create deployment policies based on container image metadata. So these policies can be based on attestations such as a vulnerability scan or other types of signatures, such as maybe being built by a particular pipeline or having gone through a specific QA process. Again, this ensures that only trusted images are deployed into your environments. So let's put all this together. So when code is checked into GitHub or your source code repository, it triggers a build and cloud build. Cloud build then generates a new container image. It will create a build record of that contains information on the image, including the location, the source code from which the image was built. And then that triggers a vulnerability scan. So the vulnerability scan is done. The results of that scan are stored as part of the metadata for that container. And as mentioned on the previous slide, you can configure binary authorization to require attestations based on the vulnerability scan results. So this prevents images with known vulnerabilities beyond a certain level, so maybe say high, from being deployed. You can also have other requirements like only allowing images from trusted sources. So if someone tries to deploy one of these unauthorized images, binary authorization will stop it. And all of this is logged in Cloud Audit Log. So now Anthos Config Management, or ACM. So with ACM, you can create common configurations across all your infrastructure, including custom policies, and apply it to both on-prem and across clouds. Anthos Config Management evaluates the changes and rolls them out to all the Kubernetes clusters so that your desired state is always reflected. So based on Open Policy Agents Gateway, ACM Policy Controller provides first-class integration between OPA and Kubernetes via a custom controller. So this turns Rego policies into Kubernetes objects, allowing them to be customized and deployed using your standard workflows. When Policy Controller is configured, incoming objects can be denied admission into your cluster or audited to see if they violate governance policies. So we offer quite a few sample policies that you can use with ACM. They include policies like requiring services to disable unauthorized access or label enforcement. But more specifically, with our Anthos PCI blueprints, we include policies to help enforce TLS. And again, this helps enforce PCI requirement 4, which talks about encrypting data in transit, specifically of cardholder data across open and public networks. So as you can see from this slide, looking at some other common controls, we can see how services like binary authorization or policy controller and Anthos config management can help. And then lastly, we tie all of this together by mapping the various components and policies in the blueprint to PCI DSS 3.2.1. And we also include a PCI white paper. So the white paper provides an independent third party assessment of the blueprint performed by PCI auditors. This not only gives you, our customers, more confidence in our solution, it is also something that you can provide your QSA as part of your audit, which hopefully will help speed up your assessment. So, to learn more about this or our other blueprints, schedule a session with your Google team or check out the links here. So, there's one for Google Cloud and PCI and one for our security blueprints. Thank you.